Before we move on to discussing variable scope, which leads us into the heart of C# and object-oriented principles, which in turn refocuses us back onto Unity, I want to quickly go over some basics in regards to code structure versus strictly enforced code syntax. This relates to something that you will become intimately familiar with when coding, that's dealing with errors. Alright, so you may have already experienced a few weird errors when you were following along. Perhaps you missed a semicolon or you misspelled a word. Errors are a normal part of coding, and I want to quickly go over the topic before we go deeper into C#. The first thing you should know is that everything in C# is case sensitive. So a variable named message with a capital M is completely different from a variable named message with a lowercase m. Many errors or unexpected output often result from a simple spelling mistake, so definitely be on the lookout for that when you're first tracking down issues. And speaking of tracking down issues, one of the great things about using an IDE like Visual Studio is that it's pretty good about helping you figure out problems in your code. You will often get hints about errors or potential problems in your code by looking out for those squiggly underlines in your code. I'll show you right here. So in our code here, if I create a simple error like taking out the semicolon, pretty quickly there we see a red squiggly underline, and when we hover over it, it gives us a hint. In this case, it's pretty explicit and obvious. It says the semicolon is expected, so we'll fix that right away. So that red squiggly line, that indicates an error. If we try to run the program or we try to build it, it just won't work. Sometimes you will see a green squiggly line, such as in the case when you create a variable that you end up not doing anything with. So let's make a variable that we don't do anything in the code. In the rest of our code, we don't reference it. And there you go, we got a green squiggly line this time, which is more like a warning in Visual Studio. And when we hover over it, it says the variable nothing is declared but never used. Right? We never even assign it. It's never used anywhere else in our code. It's just declared, and then it just sits there, and that's our warning. So yeah, the green squiggly line is just a warning, which is in contrast to the red squiggly line, which indicates an error. And so when we produce an actual error that was caught by the compiler, the script execution stops entirely, and it prevents the game from running. So when you try to run your script and it has an error in it, this is called a compile time error, which is basically a fundamental error in your code, usually syntax related. That's basically saying this doesn't make sense. How am I supposed to run this, right? So sometimes we get a very cryptic message that tries to provide a clue for us into the error, but usually the most important clue is the line number being reported with the error so that we can go back and check what the error might be. So I'll show you what I mean. I'll just type in some gibberish, right? That definitely shouldn't result in a successful compilation, right? So down here in our error list, it gives us some error messages. So it correctly identifies there's no semicolon. That's pretty obvious, but even more obvious than that is that, as this error message says, the name, whatever gibberish I typed in, does not exist in the current context. That's basically saying that there's no variable that's been defined with this name. It basically means nothing, right, to the compiler. If we had a variable with that name that we previously declared, it actually might make somewhat sense, and this error may not at least appear, not this one. But what we're really wanting to look at is over here at the end of our error list, we see the line number in which it appears, right? So I mean, the red squiggly line gives us the indicator, but sometimes you actually end up with a lot of errors or several errors on different lines. So in that case, it's often very useful to hunt it down by first looking at the line numbers here on the right hand side. So yeah, error messages can be very obtuse, even to experienced coders. So don't freak out if it seems like total gibberish or to be speaking in a totally different language. But yeah, another error you may see when you're naming variables and methods is if you use an invalid character. So I'm not going to go over all the symbols you shouldn't be using when naming your variables and methods. And instead, I'll just generalize it with a basic rule, a rule of thumb, and that is to use only alphabetical characters. And if you feel you have to include a number, like we did with our different method names, we postfixed with a number. Postfix it. Don't prefix it. It just won't work. So alphabetical characters only for our names, and postfix with a numerical, a number, if you absolutely feel like that's necessary. So here's an example if you want a variable to store a winning percentage. Name it something like this. Let's get rid of this gibberish. Name it something like, well, it's going to be doesn't matter. It's going to be a winning percentage, so it's going to be a float. Name it winning percentage, right? That's valid. There again, we see the green squiggly line because we're not doing anything with that variable just yet. So that's a valid variable name. Don't do something like this. All right? That's not valid because the percent sign is not an alphabetical character or a number at the end of this variable name. Also, if you have a multi-word name like winning percentage, avoid using an underscore between the words and instead rely on camel casing, what's called camel casing or Pascal casing, to separate the words. That makes it a little bit more visually appealing and easier for you to understand. So this would be camel casing, right? All right, that's camel casing because it sort of resembles the humps on a camel's back. So the first letter is lowercase, and then we also have Pascal casing, like that, where you capitalize the first letter of each word. But yeah, in both cases, you wouldn't separate the words because that would actually be basically creating the name or identifier for two variables, right? So that's strictly forbidden. And a general tip for you, especially as a beginner, you may have seen some people who write code using very cryptic and short variable names. I would say err on the side of being descriptive. Even if the names start getting a bit long, it's much more important to be able to look at your code and quickly see what's going on, especially when a lot of time has passed since you first wrote it. And I guess the last thing to keep in mind with regards to creating custom variable and method names is that you can't use what's called reserved words. The C# language has many reserved words which will show up in blue font, just like you've seen with the types we've been using, like int, string, etc. So whenever you see this special color coding, just know that you can't use that as your custom identifier for a variable or a method's name. All right. So next thing I want to talk about is code formatting. C# as a language relies on explicit characters to designate where code blocks begin and end, which is curly braces, right? And where statements end, which would be semicolons. So because of this, the practice of indentation and white space is pretty much purely for readability. So in principle, you could put all of your code on one long line. You know, it would be terrible for readability, but it would not result in errors since the compiler is able to properly understand where your code blocks and statements begin and end just in the syntax alone. So the guideline is to indent a single tab for all lines within the immediate code block. As you've been seeing in our code so far, that's been the case. And actually, you've probably noticed that Visual Studio defaults to naturally implementing this indentation structure, right? So when I make up a method, I press enter and it creates the curly braces, and it creates the indentation for me, create an if statement, same thing. It creates this natural indentation structure. All right, you should just go along with that. No need to create your own. That's just a general rule of thumb when coding for readability's sake. Now, when it comes to empty code lines, to more clearly visually separate variables or visually group elements together, this also comes down to personal taste. So, for example, when we grouped these variables here in our method called stateHandler, maybe it would have been a little bit more visually easy for me, especially if I have a lot of variables, to separate my ints from my bools just by adding some white space, right? But it makes no difference to the compiler whatsoever. So Visual Studio is an invaluable tool to help keep our code neat and tidy, but it also helps us reduce the chance of producing errors in the first place. And one of the first lines of defense in Visual Studio is its built-in code completion feature called IntelliSense. You may have already stumbled across this, where elements that have been already declared in your code can be automatically detected when you start typing and allow for quick and flawless auto-completion. Right? So here in my code, we've already declared damage rating, right? So if I start typing damage rating, just a couple of characters, and it already pops up. It anticipates with IntelliSense that I'm going to want to reference this variable. So when IntelliSense pops up, all I have to do is hit tab and it automatically completes that variable name. A really handy feature. IntelliSense is really great, not only for reducing errors caused by stuff like misspelled variable names and whatnot, but also for giving you a hint as to what's available to you in certain contexts in your code. And it really helps when you're coding and are accessing the Unity API as a real-time list of options available to you. So IntelliSense is something we'll be using quite often from this point forward. But that's all I want to say about that. We'll go more into this and show you the beauty of IntelliSense as we cross the Unity API, as we cross that path. So all in all, we've looked at how to keep your code tidy, hopefully error-free, and how to go about fixing errors if you do get them. But in the end, probably the best tip I can give you is simply this: to not write a lot of code before you send it off to the compiler. You know, before you build a code or press play, the play button in Unity. In fact, you should get used to building your script to check for errors almost without thinking about it, almost automatically. And sometimes nothing more than a few lines of code. You should just be hitting the build button, or else the shortcut, which is Control Shift and B. So here when I go to my code, if I hit Control Shift B, shows build started down at the bottom, and it shows the build details. Again, you can go to the error list if you get errors, which we didn't, and it says build succeeded. But if we do have an error, such as, again, I'll take out that semicolon and Control Shift B to build it before even pressing play in Unity. This is a quick and simple way of testing my script. All right, so if you check for errors often, it'll just be a lot easier to track down the errors without having to systematically dismantle your code in order to isolate where the error might be coming from. So it's just a good general tip to keep in mind. So that's about all I want to say about these topics for now. We will certainly keep referring to suggested coding standards, error handling, IntelliSense, debugging, and all that as we move along. But for now, I just want to get the basics out of the way. And in the next video, we'll be going back to coding and get a look at variable scope. See you there.